is to remind me to start the recording when the session begins, like right now. Okay, so the recording's going. If we look at slide number 1, I've numbered the slides again. Slide number 1, I put my phone number on this slide. And I really encourage people who want to talk to me about anything that has to do with brain science or this presentation. I'm really open to hearing from people and going into more depth, because I think this is something that is currently informing the direction the whole world is going, but certainly Western culture. More and more every day.
Mark, is there any better time during the day to get you than another?
Well, I'm usually up between 3 and 4 in the morning, Pacific Coast time, so that's always a good time. But no, I mean, if you call and you get a recording, then just leave a message and I'll be happy to get back to you.
Okay.
Yeah. So these sessions are going to be set up similarly as last time. There's going to be 10 questions. But before we get to the questions, I want to point out that we're giving equal time to the female brain here in session 2. You see this woman on this first page. And notice the beautiful cerebellum there, the base of her brain, right? And you see those internal structures. And we're going to do a review in a minute. And the reason we're going to do a review is because one of the ways, of the many ways, that the brain learns things is by repetition. Okay, so if we go to slide 2, this is the place where we pause. I'm going to ask you to load up session 1. And I'm just going to go through it. I'm going to click through the slides. We're not going to only make, passing mention of particular things from session 1. And as we go through the slides, just look and see what you remember, and look and see the difference between remembering and recalling, right? When you see things, they're liable to trigger memory, like on the first page in session 1, you see the man's brain. And he's also got a big, robust purple cerebellum there. And we're going to go through in full screen animation mode so that you get to see all the pieces. And I will be announcing the slide numbers that we're on as we go. And so this is just for the purpose of review, okay? And see if it makes a difference in retention. All right. So to slide 2, picture of me sitting on a log, close up, and then 5 brief things. And then slide 3, a definition of social neuroscience, and the one we'll be using is how the brain affects human relationships and how human relationships and environment affect the brain. And environment means everything that's outside us as well as everything that's inside us. And that's an important distinction, because often our internal environment is affecting our neurophysiology in ways that are less than optimal. And as we go through this week and the next couple weeks, we'll begin to see some of the ways that our internal environment really compromises our functioning in the world. And these are ways we may have intuited, but now we have a greater understanding about how that happens. Okay, slide 4. Again, the 10 questions, and then we'll go through each question on the subsequent slides. Slide 5. The color presentation of the brain and many of the parts. I pointed out Broca's area and Wernicke's area, which I'll talk about a little bit later tonight when we get to the stress part. I just saw a really interesting example of how stress compromises the speech and language areas of the brain. And I'll talk about it and I'll give you an opportunity to go look at it on the internet. The next animation here shows the internal structures, showing the amygdala and hippocampus and the hypothalamus and thalamus. And if you remember last time, I told you you don't really need to spend a lot of time learning the names of parts and their functioning, because as we go through these sessions, it will become apparent. You'll learn a lot about them and what they do in their names just in the course of our conversations here. Got that, Ruth?
Yep.
Jennifer?
Yep.
Okay. Slide 6. Basic neuron. And before the last session, I asked you to take a look at that 4-minute video, right? That's going to be a really important one to review over and over, I'm discovering. Because action potentials run the world. All right? So I would encourage you to watch that video again if you didn't quite get it the first time. And then 3 different types of neurons, and then the organic sugar comparison to how small brain cells really are. 100,000 in a piece of brain tissue the size of a grain of sugar. That's small. And then 7, we looked at the difference between a neuron and a nerve, and basically a nerve that runs all through our body. It's part of this distributed information network. Is made up of neurons, long tails of neurons housed basically in the brain. Right? And you can see the collection there in that cross-section of a nerve. And then we showed the different nerves running throughout the body. You know, here it is, that distributed information and energy processing system. And I'll say that phrase over and over again because it's a really useful way to think about how the brain and body work, especially when it's not working optimally. All right, and then we introduced the cranial nerves and the mnemonic device, and then the black and white picture of the nerves distributed throughout the head. And in terms of social neuroscience, these nerves, and we'll come to this in several sessions up the road, play a really huge role in social neuroscience. And then the last piece on slide 7 is the ways that nerves can malfunction through compression, sheath loss, disconnection, and degeneration. And so if we're not processing energy information well, then it's good to know what kind of difficulty we're having, right? All right, and then our slide 8, are everyone's neurons and brains the same? And I want to stress again, every single one of our brains is uniquely our own, modified by experience and environment, internal and external. And then the last animation here shows a bunch of different neurons in the cortex, the 6 layers of the cortex. It's really interesting to look at this illustration because it looks like there's this wide variety of neurons spread over this huge depth. In reality, this collection of neurons is contained in a thickness of cortex that's about the thickness of 10 sheets of copy paper. That's it. Okay, slide 9. What makes neurons and synapses grow? Novelty, unexpectedness. And, I didn't mention this last time, stress that doesn't generate overwhelming stress hormones.
Mark, I was struck by these words are actually stressful words.
Some of them, absolutely.
And so I'm assuming that being startled,
Right.
for instance, having something startling happen in your life, it makes your neurons and synapses grow, but it also could be a problem, right?
Absolutely. So if you're in say a work setting where you're constantly being startled or upset or surprised, and the stress levels don't abate, then that's adverse.
Yeah.
That's problematic for the brain. And we'll see why when we get to polyvagal theory and adverse childhood experiences subject. Yeah. Slide 10, a sidebar, talked about, illustrated how the environment affects our internal experience, right? And I put these pictures up to illustrate that. Slide 11, do all living things possess neurons? And I introduced some of the helpful animals that we've learned so much about the human brain from, including Aplysia, the California sea snail. And then slide 12 introduced the difference in brain integration connection. So these brains might actually have a similar number of cells, but they have many, many more connections in Gauss's brain. And that makes all the difference. And then slide 13 introduced left brain, right brain, kind of a debunking of one hemisphere being solely responsible for one function versus the other. No, it's an integrated system. And each side can take over for the other if it needs to, so long as the connections across the middle and the corpus callosum are intact. But not only is it a distributed system across the hemispheres, but it's a distributed system throughout the body. And that's really important to remember. I just read a research study where they have developed a way to disconnect traumatic memories in the brain, neurons that are holding traumatic memories in the brain. Well, the body's also involved in traumatic experiences, and it records those experiences. And that's going to be a really important consideration down the line when we explore, just how trauma does actually affect the body. And then slide 14, pause for questions. 15, do neurons get born, die? Neurons are getting born and dying all the time. And again, environment plays a huge role. Environment determines what proteins express different genes, which express epigenetic regulators, whether a cell grows to full maturation or whether it dies, immaturely and prematurely. And we'll just, when we get to neurogenetics, we'll talk a lot about how that process works and ways to positively influence it. All right. I put in the real names for all those abbreviations just in case people were interested. Slide 16, good cell death and bad cell death. And then necrotosis, a hybrid of good and bad. So this is a really important concept to remember. Cells are dying and being born all the time. But the way they die makes all the difference, as I explained last time. And then conditions associated with elevated inflammation, there's a bunch of them. Inflammation response lowers cognitive ability. It's a really important piece to remember, okay? And it doesn't tell us that we have, it was really interesting for me to work at, this think tank at Stanford for 10 years. Because what I came to realize is that these are some of the smartest people in the world. And what I came to realize is they're not smart all the time, right? Especially when they're placed under stress. In fact, some of them may be more susceptible to stress because so much of their lives have been focused in one area of expertise, right? Okay, slide 18 is just a graphic illustration of the brain as an information and energy processing network. And then another depiction of it with ones and zeros and blue action potentials firing, right? And then 5 personality traits I introduced about how brain optimized to process energy information really makes us, really produces a personality that we like to both exhibit and spend time around, right? Slide 19, what happens to the brains and bodies animating energy when death occurs. And I put this in here because so much of what goes on in our lives under the surface, under conscious awareness, is oriented toward avoiding death and promoting life, right? And so for many years, I was deeply immersed in what I call death culture, death and grief culture, because I was wanting to turn toward this thing that I was absolutely terrified of, right? And so this is a physicist talking about what happens when we die. And, it's one thing to take the cognitive understanding of it, but it's a whole other thing than to integrate both what I would call a emotional and a spiritual understanding, to take it actually into the cells of our body and have it be part of the very fabric of our being. That's a very different experience. And then finally, 3 resources offered up for people to explore stuff further. Okay. So that's a brief review of the first session. When we do this next time, I'm probably not going to speak so much about the topics. I'm just going to scroll through them. I thought I'd experiment this time with making comments. I think it's actually, it'd be an interesting experiment. And I'm happy to get feedback to see which one, which review feels like it's more engaging. Me speaking or just a silent going through the material. We'll try that next time. Okay, on to session 2. So does that make sense, Ruth and Jennifer, for
Yes.
learning to actually review things like that?
Yes, that was very helpful.
Did it feel like it solidified some of the ideas and concepts a little bit?
It did, and I found I picked up some things that I missed.
Okay. Well, see, this is really interesting. So I'm a great fan of reading books more than once.
Right.
And what I discover every time I read a book that I've read before is not only did I miss stuff, but I discovered that my brain has actually significantly changed since the earlier reading. So in a sense, I'm reading a very different book than when I read it the first time because I'm a very different person. Does that make sense?
Yes.
So about 5 years ago, I read Bob Scare's book, The Trauma Spectrum. And there's a lot of neurophysiology and neurology terms that I was vaguely familiar with. And then I recently read it again, and it's like it's a whole new book because I understand so many of the terms in a different way than I did before. It's like integration has happened. Yeah. All right, so let's go slide 3. So each session I'm going to be asking or suggesting something to review before the session actually starts. So this time it was Alex Ciaris's TED Talk, which is a 10-minute talk, which is basically the first question on this 10 questions list. So I just scrolled through the 10 questions, and I'm not going to read them as they come up, but we'll read them as we get to each slide. All right. So slide 4. What does quantum mathematics have to do with pre and perinatal encoding? So this is basically in reference to Alex's TED Talk, right? And part of the reason I asked you to watch that, is because it's just astonishing, and I mentioned this before to folks that were online, how much information, how much, the way he talks about it in mathematical terms is instruction sets, is contained in 2 cells. You know, all of us have grown out of this fusion of 2 initial cells containing all the mathematics, all the ones and zeros that we need to generate 60,000 miles of blood vessels and capillaries, to unfold a heart, to unfold a brain, eyes, all the sensory apparatus, all the organs. It's absolutely mind-blowing. And so when we continue in this program, in these sessions, what we'll discover is all the different ways that those instruction sets, quote unquote, can be compromised, right? Compromised by early environment primarily, but also later environment, right? Jennifer talked a little bit about, doing the work of recovering from medication that changed her internal environment. Initially, probably for the better, or better than it was, but then it had long-term consequences. Yeah. So then we have a picture of, I don't know if you know Alex Gray's work, but he's this pretty compelling artist. And I put up his illustration of the developmental phases of conception through early stages of development and then birth. In the Alex Ciaris video, he was really amazed by mostly it seemed to me, by the fact that not only can we make human beings, but in that those instruction sets are information for how to then design women to be able to carry and bring to full term additional human beings. If like just making a human being wasn't enough, we're going to actually make a human being that can make a human being. That's absolutely astonishing. Okay, slide 5. When does the developing embryo become a person? So this is a big question. It's a question in neuroscience, but it's a question in a larger culture. And almost everybody has an opinion about it, and the opinions are important and necessary. But here I wanted to explore, and a lot of this series will be about what are some of the possibilities for reducing suffering in the world, right? Because suffering in the world is not good for the brain and not good for the body. And so here we have a pretty young embryo, and there's something called the cardiosufficiency theory, and that's at 6 weeks, the heart's been beating for 50% of the time, right? And some people think that it's at this point that an embryo has actually become a person, right? Some people think at conception an embryo becomes that an oocyte is a person, right? And in slide 6, we see, again, we're asking this question, and we see the developmental spiral as it unfolds. And then here's a perspective from Mike Zaniga, who's a neuroscientist at UC Santa Barbara. It says, a human brain isn't viable until week 23. Moral arguments get mixed in with biology, and the result is a slew of passions, beliefs, and stubborn opinion. In judging a fetus as one of us and granting it the moral and legal rights of a human being, I put the age at 23 weeks. When life is sustainable and the fetus could, with the help of a neonatal unit, survive and develop into a thinking being with a normal brain. So that's what a neuroscientist thinks, one neuroscientist. We go to slide 7. There's a study that was done in Israel, and in this study, 281 women were asked when they felt they perceived a fetus as a person, and the majority of them said they felt it was a person when they could feel the movements, right? So that's another perspective, right? And then if you look at this statistic I've overlaid onto those 4 developing cells, you discover that the miscarriage rate for 1-week-old human embryos is between 50 and 75%, making God the world's greatest abortionist. I didn't know this statistic. Ruth and Jennifer, did you guys know that?
No.
Yeah.
And I wondered actually how they figured that out.
How they figured it out?
Yeah. How did they come up with that?
Well, they did a survey study. I think it was Harris Poll, or I don't know, one. I mean, I'll get the research information for you. It came out of came out of, let's see, Deborah Blum's book, Sex on the Brain.
Because you really wouldn't know. I mean, you wouldn't know you were pregnant at that point.
No, you wouldn't until you miscarried.
But would you actually know it was a miscarriage?
Well, that's why it's probably between 50 and 75%. Because, you know, I'm assuming, I'm not a woman obviously, but I'm assuming that some percentage of women miscarry and never realize it. Yeah.
Yeah, at that stage it would be hard to determine what's a miscarriage versus what's just a very heavy period. I mean, sometimes my periods were late for a week. I mean, that's I just think it's interesting.
Yeah.
I'd love to know how that was measured.
Yeah, I would too, actually. So I'll look into that. But the point is that abortion goes on all the time, right? It wasn't something that human beings just decided they were going to do, right? It's a process and the reason it goes on is because the body has a system of ascertaining whether or not conception will result in a viable life. And if it won't, then there's processes there's another study, it was really interesting. And I have it on another slide, but not on this one. This was, again, done in Israel. There are two cities that are close to Palestine. One is Hebron, and I forget the other one. But they interviewed women who were within the bombing range of Palestine versus the ones who were out of range. And they determined that a much higher percentage of the women within the bombing range spontaneously miscarried because something in the neurophysiology told the developing fetus that it wasn't safe to be born at this time in this place.
Wow.
And there's a number of other studies we'll get to that speak to the intelligence of the unfolding embryo. So in slide 8, I have a picture, old Life magazine cover, The Drama of Life Before Birth. This is 1965. So what's this? 35, 45, 48, almost 50 years ago, we were able to see what's going on in there, right? It's pretty amazing. So here's another perspective on when life begins. And the Royal College of Physicians of Edinburgh, think it begins when intentional movement happens. Because that's signifying the brain is sufficiently developed to move parts, and movement is really critical for brain development in utero, right? And so this process called quickening during the 5th month is also considered as a possibility for when life becomes viable. So the point of all these is to just point out that there are lots of ideas and opinions, all right? We go to slide 9, we find 2 more opinions, one from Kanwiljeet Anand and Stuart Derbyshire, right? And you can see their arguments on that hyperlink at the bottom of slide 9. And so basically one says that healthy fetuses can feel pain between 18 and 20 weeks, and another says 26 weeks, right? So if you're trying to determine, when a human being actually becomes a human being, some people take this perspective. But here's the bottom line for me, and for brain development, and for reducing suffering in the world, right? And that is, every mother and every father really needs to be shown kindness, in no matter what they decide, right? Because kindness is one of the things that profoundly enhances neurophysiology. And mothers mothers and fathers who experience kindness through this process, whether they decide to, come down in favor of freedom of choice or the opposite, I forget what the term is. If they're treated with kindness, then the way Philo of Alexandria recognized, they're getting assistance in fighting the great battle, right? Be kind, for everyone you meet is fighting a great battle. And so if life starts out or doesn't start out, with the experience of people being kind, it's profoundly positive for neurophysiology. Does that make sense?
Yes. Yes.
Yeah. I mean, part of the reason I spent a lot of time on this was because when I was 9 years old, my sister, who was 16, got pregnant. And my mother and our community had no capacity to meet her situation with kindness. And it caused great suffering for everyone in our circle, right? And I know that this goes on a lot all over the world, where pregnancies are met with everything but kindness. Yeah. So slide 10. What are some things that adversely affect pre- and perinatal development in parent and in child? And so I found this great graphic that it just really moved me to look at it. It's like each baby that's born is actually a world and a universe, just like we saw in Alex's video, being born, right? And how we meet it and treat it, and the world it finds when it does become born, really has an effect on everyone involved. It ripples, actually, through all those stars in the universe behind it there. So at the bottom there I wrote, the brain develops in response to the environment surrounding it. And the environment that surrounds it contributes profoundly to the environment that grows within it. Yeah. Slide 11.
Mark, is there any way to repair damage done in utero?
Depending on the damage, absolutely. Yeah, I mean, if there's traumatic stress damage to the neurophysiology, how that will often show up as developmental delays. I mean, essentially, I grew up as a developmentally delayed adolescent, probably till my early 30s, right? And then, certain things come together. Mostly for me, it was the external environment and the circle of people I was beginning to spend time with. And then my development grew in leaps and bounds, right? Yeah, so we're actually going to talk a lot about, so the first part is going to focus on, this early piece and many of the things that can go wrong. But then, when things do go wrong, A, how can we avoid them? And B, after they have gone wrong, how can we begin to address ways that can repair whatever developmental deficiencies have been created. And we're discovering more and more every day. So slide number 11 is a sidebar. And this is I think this is a really important slide to realize, okay? And what it's basically depicting is that competition and conflict live in us at the cellular level, right? So we see here how the green cells get overtaken and get supplanted by the blue cells, right? It's like a turf battle, and the green cells are lost. And this goes on in the brain all the time. So there's a saying, you either use it or you lose it. And in the brain, you know, if you have neurons that aren't being used, they will be either removed through apoptosis or necrosis, or they will be taken over to serve a different function. So, for example, if you have the unfortunate experience of being blind, then many of the neurons in your visual cortex will be taken over by motor cortex and auditory cortex, which then gives people who are blind heightened hearing, hyperhearing, and an extraordinary sense of touch that allows them to read Braille and navigate their environment in ways that sighted people can't even begin to imagine. They have increased their capacity for processing auditory and motor information. And there have been actual experiments done where someone will be temporarily blinded with the intention of stimulating these ancillary senses to see if they can be heightened. And they can be temporarily, right? But then when you bring sight back on, well, sight needs the neurons in the visual cortex, so it it takes the real estate back, right? So in some ways, it reminds me of things that go on all over the world, these conflicts that go on all over the world, right? For turf and property and dominance and power. The challenge and the skillful thing then is, how do we manage something that's natural, right? Well, one, kind of a useful example would be something like the Olympics, right? That's a fierce competition, but it's structured and there are rules. And it allows people, because competition can really inspire us to great accomplishment, right? And that's what happens in places like the Olympics or professional athletics, right? Yeah. But I just thought it was really interesting to see that this actually goes on at the cellular level. Okay, so the next slide is dark. And then if you click on the animation, what it comes up with is the dazzling darkness. And I put this in here because I just recently ran across, it's a Buddhist concept actually. And it talks about what the experience of consciousness is before birth, but also after death, or in the process of dying, where we discover that life, how do I want to say this, that there is something beyond our ordinary consciousness that we develop in utero and after birth, right? And what's required I believe, to get in touch with that is to increase our capacity for processing energy and information. All right? To consciously be aware of it. All right? And so let's look at slide 12, and it's a sidebar, another sidebar slide. This is connected to that. So we've known for a long time that the brain does not develop uniformly, right? One side grows with a growth spurt, and anybody who's been a child and remembers it or has had children recognizes that, you know, some pretty profound and dramatic growth spurts can happen virtually overnight, right? I'm sure Ruth and Jennifer, you know about that experience.
Yes.
Absolutely.
Right now I have 2 puppies, and it's just fascinating to watch them change developmentally virtually overnight. Okay, so as the brain develops through these different periods, I put a question there. What happened here on the left at around 2 years, right? And this is really a useful and important thing to understand, and that is language happened.
Mm-hmm.
Right around 18 to 24 months is the generally accepted window for when language needs to be learned. Well, guess what? From that period up and when language begins to be learned, to some earlier period in utero, an enormous amount of learning was going on. You know, learning language is not the beginning of all learning. It's just the beginning of learning to put words to our experience and to the world, right? So the period in utero, and this is 1987, so they don't show the in utero period on it, has been termed by psychiatrists the unthought known. So why is this important? Ruth, why is this important? Gotcha, didn't I?
I'm not sure.
Well, the reason it's important is because we have a whole host of learning that goes on that we don't have words for, right? But what we do have is imagery and somatic sensation. Okay? So let's say you're one of these babies that's born in Israel, and you're born in the city that's closest to the bombing, right? You're going to be born to a mother who's under significantly greater stress than someone who's farther away from the bombing, right? So that stress gets communicated to you, but it doesn't get communicated in words. It gets communicated in stress hormones and anxiety and in language that you don't recognize, but you have learned to pay attention to, because mother's voice is one of the primary drivers of neurological development in utero. Does that make sense?
Yes. The term unthought known
Yeah.
was confusing to me.
It's supposed to be confusing. It's paradoxical.
Okay, good.
How can we know something if we don't have words for it?
Right.
Well, the way we know it, one way we know it, is through this process called neuroception. And another way we know it, remember, the brain is a distributed network, and it distributes its wiring all through the body. So one way we can know about life outside the womb before we've actually exited is how these stress hormones and other experiences affect our body, affect the organs in our body. There's this really interesting study that was done during with babies born during World War II in Holland, and the Germans had blocked access to Holland, and there's this historical event called the Dutch Winter, when many of the pregnant mothers were on the verge of starving to death. And so all the babies who were born after the war was over, or during the war, but then subsequently when the blockade was lifted, all these babies were born into a world that they believed was short of food, that they were born into a famine world. And they developed significantly different than babies who were born into a world of plenty to eat. Right? So they had apprehended in utero a condition of the world which was true at the time that impacted their neurophysiology. Right? But the point I want to make about this is just what Lenore Terr says. She's a child trauma expert. A whole life can be shaped by an old trauma, remembered or not.
Mark, you know that there's a whole decade or 2 decades of people raised with Dr. Spock,
right?
Who said do not feed children except on schedule,
right?
And so there are also in America a lot of people who believe that food is scarce.
Right. Right. So think about it. If you think it through, so you have this energy and information processing distributed network, and some of the cells in the brain connect to the stomach, right? So if you are a baby and you have been taught or you have experienced only being fed at a certain hour, what do you learn to pay attention to? Well, you can't pay attention to your stomach telling you you're hungry because you don't get fed when you're hungry, right? Yeah. So over time, you begin to learn to pay attention to the clock when it's time to eat, completely ignoring, any sensations in your body that are better indicators of when and what you should eat than anything else. Yeah, so that was Spock was right in many things, but he was not right in that. And here's the other problem, or one other problem. It takes an enormous amount of work to feed and care for children and feed them when they're hungry. Right?
Yes.
You basically have to be paying attention. And if it was my job to change the world, I would devote huge amounts of resources to mother and infant care for the first 5 years. Yeah. From conception to the first 5 years. And I can guarantee you that would totally transform the world. First of all, it would signal that we are a community and a culture that values mothers and children and treats them with extraordinary support and kindness, right? And there are a growing number of programs around the country that actually do that. So we're going to talk about neuroception in an upcoming session because it's a huge concept. And basically, I'll introduce it here. I've talked about it in the blog. It's threat detection without awareness. I'll say that again. Threat detection without awareness. So our body knows there's a threat, but it never makes it to conscious awareness. Nevertheless, it does respond. And we'll examine and explore some of the ways it responds in future sessions. It's a really fascinating concept. It has huge implications for everything from work environments to education to religion to politics to law, everything. All right, slide 13, Tale of Two Neurons. Here's a quote from one of my favorite interpersonal neurobiologists, Lou Consolino at Pepperdine University. We find ourselves embedded in cultures that are mismatched with our neuroanatomy, neurobiology, and basic social instincts. One only has to watch the nightly news to see the myriad ways in which human beings struggle and often fail to cope with this mismatch. In one way or another, we are all a little like Crocodile Dundee in the big city, or 5-year-olds on our first day of kindergarten. We basically have a tribal brain, and we have lost touch with the tribe. All right, so impoverished and enriched. So if you click on slide 13 and you look at the comparison between these two distinctly different neurons, it's really easy to see which one has the capacity to process more energy and information, right? Ruth, you're familiar with Findhorn, right?
Yes.
Well, don't these neurons on the right look like the vegetables that Findhorn used to grow?
They still grow them.
They still grow. And how do they grow them?
They grow them with enhanced energy, basically.
Yeah.
They grow them with with kindness, with good soil, with focused energies, with wood spirits, plant spirits. I mean, they use it all.
Yeah, with great intention, great awareness.
Mm-hmm.
Yeah. Well, the same thing that grows all those super veggies at Findhorn can grow neurons in our brain and body. All right, so if we look at slide 14, we're going to deal with the impoverished first. And I've put a bunch of collections of things that work to impoverish neural development. And obviously this isn't all of them. This is a few of them. And all you have to do when you look at these this list, a more extensive list will be in the next slide, is imagine how your body feels in each of these experiences, like when we feel helpless or humiliated, or if we're unfortunate, have the unfortunate experience of being sexually abused, or we grow up in a family where there's no irrational commitment. And basically an irrational commitment is you're born to parents who there's absolutely no question of their desire to have you and to care for you and to love you. Many children don't grow up in that environment. And then the BBQ no is the big brain question. And we'll talk a lot about the big brain question when we get to attachment and how important attachment is for human development. Any questions on these few?
No.
None here.
Okay. Well, you're all familiar with these. So here's a more extensive list. And it's not a full list, obviously, because there are many things that affect neurons and how robust they're able to grow or not.
One that surprised me was general anesthesia.
You know, I was just going to talk about that. Okay, so neuroception, remember that?
Yes.
Unthought known, remember that?
Oh.
So think about it. You're basically put under anesthesia, and what anesthesia does is it knocks out your conscious awareness, right? Well, a preponderance of the sensory data that we take in any moment, and we'll look at some research that shows up to 99% of the things that we take in at any moment is unconscious. You know, it's like our sense of touch and taste and smell, unless something is really noxious or pleasant, we're basically not paying attention to, right? And our vision and hearing are our primary senses, and especially under stress, those are considerably compromised. Well, under general anesthesia, conscious awareness is knocked out, but guess what? Body awareness is not. The body knows exactly what's going on. It just doesn't know it in words. And oftentimes when people come out of anesthesia, what they will find themselves doing is discharging the freeze response, shaking, right? Like you're coming out, like you're going into shock. Because you basically had, somebody cutting you open, and you're unable to move. You're unable to get away, and you're unable to fight, and you just have this experience, right? Hopefully I never have to, but if I ever have to go for an operation, I want the people in attendance to treat me as if I was somebody they really loved, and that I was wide awake and could hear every single thing they're saying. And that their primary job, in addition to whatever they're doing surgically, is to keep me calm and reassure me that everything's just fine.
Mark?
Yeah.
You'll also want the nurses afterwards to take very good care of you.
Yes, I will.
I've had a handful of major surgeries, and every time I come out of anesthesia, I used to shake and shake and shake, and they would actually give me drugs to stop the shaking. And knowing what I know now about trauma, I wish to God they had just let me shake it all out, but they stopped my body from doing that and harmed me even more.
Right. Yeah. And it's not deliberate and it's not malicious. It's they just don't understand neurophysiology. Right. So this is not a total comprehensive list. This is just a number of things that happen in our lives that simply do not support optimal neurological development. These are impoverishing experiences often. But again, I want to reiterate that they're unique to each and every one of us. Your poverty may actually not be a impoverishing experience. It may be something that causes you to grow rich neurons because you don't want to ever experience poverty again, right? Malnutrition may be something that you use to inspire you to become a nutritionist. So the point I'm making here is that these are generally considered to be impoverishing experiences, but they don't have to be. I want to talk about this last one, yelling. All right. Growing up, most kids get yelled at. And when I used to teach classes at university, what I would do is, when I'm introducing this topic, I would get a Confederate to stand in the back of the room, and at my signal, I would have them scream at the top of their lungs. Now, I can just tell you about that, and people on this call can imagine how their body would respond to that experience. There'd be this intense adrenaline rush. You'd turn around and orient in the direction of the scream. You'd assess whether or not there was any real danger. And then gradually, once you discover that this was an experiment, you begin to have cortisol come on and reduce the adrenaline response and bring you back to homeostasis, right? Well, if you live in an environment where loud noise and or yelling goes on all the time, your adrenaline, your body is being constantly flooded with adrenaline, and you have to do things to accommodate the neurophysiological response to that situation. If you work for a boss who yells all the time, he or she is basically making your brain function suboptimally. We do not perform well under excessive stress. All right. Slide 16, how do mothers' stress levels affect fetal brain development? So this is a TED Talk that I recently watched, Kelly McGonigal. And it was a really interesting talk for a number of reasons. One reason that I found to be interesting was when she was done, she got a standing ovation. And what she talked about basically was that she used to tell people and her clients and students that stress was bad for you. And then she read a study that said not that stress is bad for you, it's believing that stress is bad for you that's bad for you. So you see the difference there?
Yes.
She read a study that said stress isn't bad for you, it's the belief you hold about stress that's bad for you. So she stopped telling her clients that stress was bad for them. Right, so I was listening to this talk and I was thinking, well, this is weird, because how could you actually understand stress and the stress research? Because all the stress research I'm familiar with says that not that stress is bad for you, it says that excessive stress is bad for you that doesn't abate, that doesn't bring you back to some resting state of homeostasis, right? And so she made another mistake, and I consider it to be a mistake. She read this study, and she made the error of attributing causality to correlation. And this happens all the time in science. And I want to bring it up here because even I'm guilty of it. And I know better, right? Just because we find some results from a scientific research or experiment doesn't mean that the variable we're studying caused the result we're obtaining, okay? So a study that says believing stress is bad for you doesn't mean that believing that stress is bad for you causes it to be bad for you. It simply means there's a correlation and that there are many, many other variables that could be contributing to the outcome. This is an important piece that I want to stress here, okay? Because this is she's a Stanford scientist, and getting a standing ovation at 10, she's making this fundamental error. So it behooves us all to read scientific research, including stuff I'm presenting, with a questioning, I don't want to say skepticism, but just curiosity. That'd probably be a better way to think about it. So if you go to 16A, you see a ton of studies that confirm, at least in my mind, that acute and chronic prenatal maternal stress is associated with many, many adverse experiences. And it makes total sense to me based on what I know about how the brain works and how stress hormones affect the growth of neurons and neural connections. Acute and chronic prenatal maternal stress impoverishes neural growth. Whether you believe it or not.
Would that include being sick?
Say again?
Would that include being sick while you're pregnant?
Being sick? It depends on how long and mother's state of mind and body while she's sick.
Mm-hmm. I'm just thinking
about
all the people who are really sick during the pregnancy.
Yeah. Essentially, what it is most strongly associated with the degree of stress hormones that are generated that affect babies' neurological development. But here's the good thing, the brain is extraordinarily plastic. And even though a baby may be born with impoverished neural development and delayed in their development, they can catch up when they're placed in a different environment or a healthier environment. And I'm sure that we've seen that, right? I mean, personally, I feel like I'm an example of that. Yeah. So, let's see, 16A, 17. Again, at the bottom of 16A, I wrote, pregnant women and fetuses need to be given highest priority. And if they are, the benefit for all of us would be extraordinary. Okay, slide 17. Here's the basic stress response, right? We can't have no stress in our lives because we end up feeling all this, stuff on the left side of the stress curve. And we can see that as we go higher and higher and higher, we become more and more engaged and involved and effective and creative and decisive. But there's a point at which we reach optimal stress engagement. And here's the problem for what I see in my own life and I see in the culture. And that is, once we've jumped the hump, I like to say, there's no alarm or bell that goes off and says, oh, you crossed the line, you're in the high stress area now. Oftentimes, the only way we discover that we've crossed the hump is we either get sick, or we have an accident, or we make mistakes, or we discovered that our brain and body are not processing energy and information optimally. Does that match Ruth and Jennifer, your experience?
Yes.
Yes.
Yeah.
Only in retrospect.
Exactly. But here's a really cool piece. By learning to pay attention mostly to our body and how it feels, we can discover much earlier when we're overstressed, and we can take steps to reduce the feelings of stress. So it's not on your folks' slide, but I was watching news the other night, and there was a segment that came on that was talking about a contestant on Wheel of Fortune, right? And he had just spun the wheel, and he landed on the $1 million slot in the wheel, right? And his puzzle was a 3-word thing that he had to identify, and all the letters in the 3 words were filled in but one. And the answer to the puzzle was corner curio cabinet. I don't know if any of you have seen this, but it's really, it just underscored for me how stress works to compromise your capacity to process energy information. So the only letter missing was the B in cabinet, right? So the contestant elected to solve the puzzle, and he looked at the words on the screen, and what came out of his mouth was corno curo cabinet. And he lost the prize. And I could just see in his brain the stress areas profoundly affecting Wernicke's and Broca's speech and language areas. Right? You could almost see the neurons contracting and shriveling up as he's trying to read these words that he clearly knows. And he actually later went on the Jimmy Fallon show and announced to the whole world that he could say corner curio cabinet. But the stress of it just totally compromised his brain. And so it'd be interesting to pay attention to these kinds of things in our daily life, right? To see when we make mistakes and when we, feel out of sorts and when we suspect, that we may have jumped the hump. All right, then slide 18, I was going to pose for questions. Ruth and Jennifer, any questions at this point?
I don't think so.
No, I don't think so either. This is really good.
Very clear.
Mm-hmm. All right, so I'm explaining it, and I'm not confusing you, and it's pretty clear.
In fact, the opposite. I'm beginning to piece together some of my own life and around these slides.
Yeah. Well, that's what I encourage people to do, and there might be a tendency for regret or recrimination, but again, it's really important to remember this is all new knowledge. This knowledge is like the last 10 or 15 years, since we've been able to image the brain, we've begun to understand how these things actually work. Yeah. All right, slide 19, homunculus. So for those of you who don't know what a homunculus is, it's basically an illustration that depicts how neural real estate is distributed in the brain. So you can see, the hands, motor movement. We talked last week about cerebellum. Huge amount dedicated to hands. And then mouth and head and ears. Right? So here's a piece that, this is my personal pet peeve, I guess because I'm a guy, but also because I understand how circumcision affects neurophysiology. Again, we come back to unthought known and neuroception, threat detection without awareness. I don't know if any of you have attended circumcisions, but basically if you attend one and you pay close attention to the infant, you'll discover that something profound has happened. And here's Joe Quinn, who's a pediatrician and who's witnessed more than his share of these. And here's what he says. Only by denying the existence of excruciating pain, perinatal encoding of the brain with violence, interruption of maternal-infant bonding, betrayal of infant trust, the risks and effects of permanently altering normal genitalia, the right of human beings to sexually intact and functional bodies, and the right to individual religious freedoms, can human beings continue this practice? So basically what he's saying is this is a practice that we would never even think of doing to a full-grown adult. But for a variety of reasons, we do it to infants. And I can almost connect the dots for you and show you, the different ways that this practice profoundly alters neurophysiology, and not in a good way. He just listed a few of them. So I wrote here, the body keeps the score and the brain maintains a record. And we'll come back to this over and over and over again, right? Yeah. Slide 20. How does learned helplessness affect the developing brain? So learned helplessness is a really problematic learning that goes on in our culture. And basically, it's a neurological process. And remember the action potentials from last session, where a positive charge spikes and then sends a charge down a long axon and connects to another axon, and the action potential is propagated, right? And this is how everything in the world happens that has to do with human beings, except when it doesn't, right? And when it doesn't, it's caused neurophysiologically by inhibitor neurons shutting off neurons that ordinarily would be firing, right? This is an important process to understand, because you can actually then, once you understand it, you can actually feel how it feels in your body and in your brain. So for many years, I was someone who is probably hard to believe now, but was functionally autistic. People would say things to me and I would have no response. I wouldn't use words to respond to them. And it wasn't that I couldn't speak, it's just that the neurons in my brain that connect to the speech and language centers simply didn't function, simply didn't fire. They were temporarily shut off, right? And GABA, there coming out of that faucet, is gamma aminobutyric acid, which is the primary inhibitory hormone in the brain. So we're going to explore this. So if we look at the next slide, or the next animation on slide 20, we see the difference between learned helplessness with neural fire inhibited and the slide on the right when it's not. There's just a huge, greater number of action potentials firing, right? So when we have the experience of things like dissociation or fragmentation or depression, right? These are all experiences of the brain's ability to process energy and information being significantly compromised. And this is a graphic illustration of what that looks like inside your head and in your body. Slide 21. Research has shown that increased serotonin activity in the dorsal raphe nucleus plays a critical role in learned helplessness, commonly referred to as conditioned defeat. Other key brain regions that are involved with the expression of helpless behavior include the basolateral amygdala, central nucleus of the amygdala, and the bed nucleus of the stria terminalis. So these are just brain parts connected to, the research has determined, have connections to learned helplessness, right? And I put pictures up there to show you where these things are essentially located. But the point isn't to learn the names and to learn how they function, what they do. The point is to learn and understand that experiences we have and the way we relate to each other and the way we teach kids and the way we parent children plays a critical role in learned helplessness. I remember, and you, Ruth, you and Jennifer probably remember how when the kids were growing up, and it's happening right now actually with these puppies, the kids are growing up, they do things that cause a great deal of anxiety in me, right? Because I project into the future. Like, one of the things we're struggling with now is that we have a big dog and he plays with these puppies constantly, but he's really big and they're little and he's constantly stepping on them and he's doing things that make them squeal and pain, and we can just feel, this rush of concern that there's going to be serious injury resulting, right? So we then pull him back. And if you have that experience as a kid, depending obviously, then we're in some ways doing things that contribute to learned helplessness. It's a really tricky balance, like, what is a developing child ready to try and what is beyond their capabilities, right? And at least the educational system where I grew up basically majored in teaching me learned helplessness. And the only way I could get away from it was not to go to school, which I spent a lot of time not doing. All right, coming down to the end here. Slide 22. What should parents do who have significant trauma histories? So trauma histories affect our neurophysiology. If we grew up in a family that perpetrated traumas on us, we have been conditioned to make meaning of the world and experience the world in certain ways and feel comfortable in dealing with the world in certain ways, which may or may not be good for us. So I made a list of things that could be helpful for people who have significant trauma histories. So first of all, we need to recognize that we have one, and basically we all have one, because whether we believe it or not, nobody escapes childhood unscathed, totally unscathed. We all have experiences and incidents that have, in some way, shape, or form, negatively affected our neurophysiology. Second thing is, be radically accountable around our own afflictive emotions. And basically what that means is to recognize that when we're upset, for whatever reason, no matter who's saying or doing what to us, it's our own neurophysiology that's making meaning and apprehending what it is that we're upset about. And this is a hard one for me and most of the people I know to fully embrace, right? We'd much rather either be in a different environment or not be interacting with the people that we're feeling upset with. Does that match your experience, Jennifer and Ruth?
Yes, for me, and no. I mean, I actually have come to enjoy the resolution.
When it comes to resolution.
Around difficult situations.
Yeah. So this, I'm guessing, well, I know that this has been something that you have actually learned and become increasingly skillful with.
I've worked at it, yes.
Yeah. It wasn't always like that.
Oh, heavens, no. In fact, it was the opposite.
Right, right,
That's
exactly.
why I worked on it.
But once you actually experiment with it and get some skill and practice with it, it actually is something that, I don't know if you say you look forward to, but you know that you have a capacity
Yes.
to address, to turn toward.
It loses its power to scare you and
Right.
immobilize you.
You learn to unlearn learned helplessness.
Mm-hmm.
Yeah. It's an extraordinarily powerful way to be able to walk through the world. Next one is learn about attachment styles and work to make your own a secure one. And we'll be covering that in a future session. Attachment research has been going on for about 30 years now. And it turns out that it really is a profound way to think about and to observe how our brains develop in response to different kinds of experiences. Use the emotional experiences of old parenting to revisit and heal old trauma. Of parenting to revisit and heal old trauma. I don't know if this is true for you, Jennifer and Ruth, but the experience of having a daughter was an opportunity to go back and revisit so much that was disorganized and unskillful in my life as a kid, and not have her have to experience it.
I had the same when they put Natalie in my arms. I think truly that was the very first moment that somewhere deep inside I realized one day I was going to have to face my sexual abuse and heal it, because I didn't want that to ever happen to her.
Right, because you could see the innocence, you could see the beauty, you could see the perfection, right, of this being. Yeah. Learn about the freeze response and the importance of discharging it. It's amazing to me, because this is now at least 10 years old, the work around freeze response and polyvagal theory, and it's still amazing to me how few people professional people don't understand how the freeze response is so powerfully contributory to impoverished neural development. The body is designed to move. We showed how much neural real estate in the cerebellum and the motor cortex is designed to move the body. And when you're placed in situations where you don't have the freedom to move, then adverse experiences neurologically result. And we'll go into detail about how that actually happens and what to do about it in a future session. Learn about emotional enmeshment and practice differentiation. So this is a tough one for many parents and teachers and significant others, because basically the way we're built as social beings, we tend to feel things, right? And we tend to want, at least when we're operating under less than optimal, minimal stress, we tend to want the best for ourselves and other people, right? And we tend then, when that doesn't happen for them, to over-identify, to become enmeshed with their pain and their suffering. So this was a big piece I had to learn as a grief counselor, how to be present and engaged, but not enmeshed. And there's a distinct difference. I can feel it in my body. Practice being the adult in the house, especially around boundaries and limits. So that was a tough one for me because I was pretty lax. I remember I did a psychodrama exercise once, and I was the father, and I had a daughter, and she had done something that she wasn't supposed to do, and I just sort of said, oh, well, that's all right, don't worry about it. And I remember her feedback to me was, it doesn't feel like you really care. I thought, wow, that's interesting. So she would have preferred that I punish her or reprimand her or engage her in a way that let her know that this was not acceptable, because she knew it wasn't, and that there'd be consequences for her actions. That was a big learning for me. And then finally, on the list of what you should do if you have significant trauma history, pay special attention to instances of lost love made angry. Right? So we're going to spend a whole session on grief and loss and how it affects the body and the brain. And I just want to say here that grief is essentially always about lost love in one form or another. And it has many forms, some of which we'll explore. And so when it makes us angry, then there's problems both for us, our brains, and our social circle. Right?
Mark, may I add something here?
Sure, absolutely.
This is such a great list, but it's such a visceral reaction in my body. I just really would like to share. If you have a significant trauma history, if you know of someone who does and they're expecting, I urge you to not, and I repeat, not go to a quote-unquote traditional psychologist who is only interested in talk therapy, because you will most likely only have reenactment without resolution and cause even more problems.
Yeah.
Because it happened to me for many, many years. And if you do have a trauma history and you want to work with a professional, I encourage you to find someone who is trained specifically in helping the body and the mind, heart, brain, and spirit heal from trauma.
Absolutely. And again, this is newer research. It's not that psychologists or therapists are bad. We just didn't fully understand the role of the body in, disorganizing our neurophysiology. But it's important and it's profound. Slide 23, coming down the wire here, potential neural enrichers. So it is possible. The brain is enormously plastic, so we can take those impoverished neurons and we can grow fin-horn vegetables out of them. And so the big brain question, yes, is one thing. And I'm assuming most of you know that I made this up based on research out of Susan Johnson, a Canadian family therapist, research about what the presenting problems are who show up in her practice day after day. And it's basically one person or both people feeling like the other person isn't really there for them. And when you have that feeling and that experience, it profoundly negatively impacts neurological connectivity and development. And then contingent communication, we'll talk about that when we get to attachment, irrational commitment, we talked about that earlier. The beauty of natural surroundings, we saw on that slide about situated cognition, how powerful, beautiful natural surroundings can be. Prayer, meditation, contemplation. We'll go deeply into that when we look at contemplative neuroscience. Anything that basically works to help modulate arousal is potentially a neural enricher. I put a bell in there for this. Did you hear that?
Yes.
I'm just experimenting with sounds that you could make. So this completes, again, it's not a total, list. These are the only things that work to enrich neurophysiology. But there is a number of really ones that really work. So probably one of my favorites is 7-11 breathing, which is basically you breathe in for some count, like 7, and then you breathe out for an extended count, 11. And the reason why this helps neurophysiological development is because when we exhale, exhaling sends a signal to the heart that it can reduce its rate of beating. And when the heart can, because when you're stressed or stress hormones are flooding your system, the heart rate increases, right? So exhaling, like, you can just feel, this sense of relaxation, and that sends a signal to the brain that we can begin to relax. So heart rate decreases, and the muscles and tension in our body can begin to decrease. And it only takes a handful of breaths like that to make a noticeable difference in the way your body and brain feel. Okay, further exploration. Annie Murphy Paul's book on origins is really a great resource. She goes into so much that happens to a fetus in utero that we had no idea was taking place. And then Margot Sunderland's book, The Science of Parenting, goes heavily into the science piece. And then finally, the Journal of Pre- and Perinatal Psychology and Health, which is a great resource. It publishes, a lot of the work that is currently going on in this field of this specialty. And then it says pre-work, but it should say preview. So for next session, it's going to be, I'll send you a note too to remind you. And also I want to remind everyone that we're meeting on the 2nd and 4th Mondays of each month. So it's actually going to be 3 weeks from this session to the next one, because that's how the calendar works out. And then in Rebecca, she's a neuroscientist at MIT. She talks about her research with infants, which is really compelling, about how we actually begin to grow a social brain. And I'm just asking you to watch the first 6 minutes, but the whole talk is definitely worth listening to. All right, finally, any questions before we end?
Not from me.
None for you? All right, how about Jennifer?
No, Mark, you did a really outstanding job as usual.
All right, well, I hope it's helpful. Remember, we're basically trying to address things that can go wrong and may have gone wrong in our lives, and then what we can do to begin to implement practices and experiences to make them go much better. Yeah. All right then. So I appreciate all of you for hanging in with me here. And again, I want to reiterate, any questions or experiences you want to talk about, or explorations you want to explore with me, you can call me, email me, whatever you want to do. I'm more than happy. This is an area that I'm passionate about because it's been so helpful to me, and I'm happy that this is my full-time job for the next 6 months. All right. With that said, I wish you all a great evening, and we'll see you next time.
Thank you.
All
Thank
righty.
you.
Bye.
Bye.